All right, in this video, I'm going to be working some examples of anti-differentiation. And so this is, when you're just starting out learning how to anti-differentiate. And I'll be working through BC Homework 5.2. Okay, so I think I need to pull that up over here because I don't have a paper copy of that one yet. Let's see. All right, so the first set is just find the antiderivative. So I'm going to kind of go through that pretty quick. Antiderivative of 1 minus x plus 2x squared minus 4x to the third with respect to x. Okay, that's going to be x minus 1/2 x squared plus 2/3 x to the third, right? I'm going to increase the power by 1 and then divide by the new power. So x to the third, then divide by 3. Then minus 4x, say, to the fourth divided by the new power, which is 4. And then don't forget your plus c, right? All right. Number 2. Square root of x plus 2 over x to the 3 minus the 5th root of x to the 4. Okay, and what I'm going to also do, I'm going to rewrite this square root of x as x to the 1/2 power, just as soon as I can find my eraser. And all right, I'm going to just what? Come on, there we go. Okay, eraser wasn't working that well. So x to the 1/2. Right? Yeah. Okay. So now I'm going to, with respect to x, that's going to be increase the power by 1. X to the 1.5 divide by 3/2, or you can multiply by 2/3. But if you wanted to put it divided by 3/2, that would be completely fine. If you wanted to call that x to the 1.5 divided by 1.5, I'm cool with that too. Okay. And then I'm going to have plus 2x to the, I'm going to increase the power by 1, like add 1 to the power, so negative 3 plus 1 is negative 2. And now I need to divide by negative 2. Okay. Okay, so x to the 4/5 plus 1 is like adding 5/5. It's going to be 9/5. And then we divide by 9/5, right? We can do that. That's cool. And we won't forget our plus c. Right, here is one that's kind of a quotient. And while we will never have a quotient rule for anti-differentiation in general, ones like this that we can, kind of divide first before anti-differentiating, these are quotients we can take the antiderivative of. So I'm divided by x to the 2, and the top is 2x to, I just need to zoom in, I guess. Yeah, that's much better. 2x to the 3 minus 5x to the 5. Okay, so we need to rewrite this before anti-differentiating. So that's going to be the antiderivative of x to the 3 divided by x to the 2 is x to the 1. So that's 2x minus 5x to the 5 minus 2 is 3. Because really what I'm doing here is I'm taking this thing and I'm saying this is 1 over x squared multiplied by 2x to the 3 minus 5x to the 5. And then I'm distributing to each of these factors, or each of those terms to get these. Okay, now I'm ready to apply the power rule in reverse, and I'm going to say that I'll have increase the power by 1, divide by the new power, that's just x squared, minus 5 over 4 x to the 4 plus c. Okay. Oh, it's over here. All right, number 4. Okay. So this is equal to, okay, it's like 1 over x times 1 plus x to the 1/2. Okay. Or maybe I get rid of that and instead write it as, whoops, x to the negative 1. Whoops, there you go. Then if I distribute, I'll be anti-differentiating x to the negative 1. X to the negative 1 plus 1/2 is negative 1/2. Now maybe you remember me telling you that the power rule only works for powers of x that aren't -1. Okay, it works as long as we're not taking the antiderivative of x to the -1. But if you didn't remember that, then maybe you would know, once you went to increase the power by 1, you got x to the 0 and you wanted to divide by the new power, you were trying to divide by 0, that's a bad sign, right? So I need to know that this is log of the absolute value of x. Okay, if I increase this power by 1, I'll have x to the 1/2. And if I divide by 1/2, that's like multiplying by 2. Okay. And won't forget plus c. Now, over here, I'm going to just make sure by taking the derivative, okay, we're not really sure about the absolute value, what that means quite yet, or why that is what it is. But the derivative of log of x is 1 over x, so I'm going to feel good about that. Over here, if I took the derivative, I'd have 1/2 times 2 is 1, x to the -1/2. Okay, that's good. Plus c. Okay, so at this point, it's probably always a good idea to check your antiderivative by taking the derivative. So number 5, antiderivative of t to the 1/2 multiplied by t to the 5 minus t. And while we will later on in this course learn about a product rule for antidifferentiation, if we have two things that are algebraic, when that time comes, I'm going to still tell you that you're better off distributing than trying to use a product rule for antidifferentiation. It's probably not even going to work with this. So what I would do is t to the 5.5 minus t to the 1.5, right, when I multiply these. And this is going to be, all right, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Don't forget plus c. Number 6, we're going to distribute in a third root of x, so that's x to the 1/3 power, onto 1 and negative x. Okay, so this is going to be x to the 1/3 minus x to the 4/3. Okay. Yeah, because 1 times x to the 1/3 is x to the 1/3, and then if I add in one more power, it's like adding 3/3 to the power. Okay, so I'm going to say this is equal to, bump up the power by 1, add 3/3, that's x to the 4/3, divide by 4/3 is like multiplying by 3/4. Minus, okay, increase the power by 1, that will be 7/3, and then divide by the new power, that'll be multiplying by 3/7. Plus c. Oh man, they just keep going. Even more. X to the 3 minus 5 squared. Okay, so what we need to do is we need to remember that when I square a binomial, there's going to be, I actually need to do the distribution. This is not x to the 6 minus 25. Do not be fooled by that. Scoot that down a little bit. Okay, so it's x to the 6 from the first terms. These two copies of negative 5x to the 3rd, I'll have negative 5x to the 3rd there, and negative 5x to the 3rd over here. That'll be negative 10x to the 3rd in total, and then positive 25. Right. So this antiderivative becomes the antiderivative of x to the 6 minus to the 3 plus 25 with respect to x. And I can apply the reverse power rule, right? X to the 6, I bump up the power by 1, divide by the new power. Bump up the power by 1, divide by the new power. Bump up the power by 1. Okay. Or just know that something that has derivative 25 is going to be 25x plus c. Now, this one. It's another square binomial. Okay, so antiderivative of 1 plus square root of t squared with respect to t. Okay, got my blue pen still out, so I'm going to say that's 1 plus root t times 1 plus root t. That's going to be 1 plus 2 square roots of t plus square root of t squared is just going to be t. All right, so 1 plus 2t to the 1/2 power plus just regular t with respect to t. All right, and I'm going to get t plus increase the power by 1. That's going to be 3/2, so I'll need to multiply by 2/3. Right. This one would probably be a good one to check by taking the derivative, right? Okay, 3/2 of 4/3, well, that'll be 4 divided by 2 is 2. And reduce the power by 1, 3/2 minus 1 is 1/2. Okay, so that makes sense. Plus 1/2 t squared plus c. All right, just the two more. Oh, this one's going to be particularly relevant to the quiz next time, I think. Maybe if it was sine of negative theta and e to the 2 theta or something like that. But for now, we know that the antiderivative for sine of theta is going to be negative cosine theta. Because the derivative of cosine of theta is negative sine of theta, we need to prepare for that negativity and kind of preempt it. And then e to the thing is its own antiderivative. But if it's going to have like a constant multiple come out for the chain rule, we need to prepare for that, right? Because if I take the derivative of e to the 2 theta with respect to theta, I'm going to get 2 e to the 2 theta. So to prepare for that and make sure I only get 1 e to the 2 theta, I'm going to divide by 2 so that, you know, it has a soft place to land. And then plus c. All right, number 10 is antiderivative of cosine of 3x minus sine of 5x. We know an antiderivative for cosine is sine. We'll probably leave the inside the same, but we need to prepare for that 3x, the chain rule implications by dividing by 3. I think that would be plus cosine of 5x. But to prepare for that 5 to come out, we're going to need to divide by 5, right? To prepare for the chain rule. And then there's plus c. All right, so these problems are looking like now we're getting into the situation where we're going to actually solve for the c and get ourselves a particular solution. So f double prime is equal to 4 minus sine x. Okay, then that means that f prime is the antiderivative is going to be 4x plus cosine x plus c. And now I need to do a little bit more work to figure out what is the value of that c. Because they told me that when x is 0, f prime equals 2. So I'm going to say f prime of 0 equals 2. That gives me 2 equal to 4 times 0 plus cosine of 0 plus c. Okay, so that tells me that c needs to equal 1. Okay. So now I've got f prime equaling 4x plus cosine x plus 1, meaning f of x is going to be 4x, antidifferentiate all of this, 4x to the 2 divided by 2 is 2x squared, plus sine of x plus 1x plus some other c. And now, since they told me that f of 0 was equal to 5, then I will say, okay, 5 is f of x, that's equal to 2 times 0 plus the sine of 0 plus 0 plus c. Okay, so that means c is 5. And now, I'm going to conclude that f of x is equal to 2x squared plus sine x plus x plus 5. Number 12 is, again, we're going to get a second derivative. And we're given two initial conditions. We're going to be asked to find g of t. All right, g prime is going to be, it's going to be related to 3e to the negative t, but if you checked this by taking the derivative, you'd see that, okay, it would be 3e to the negative t times -1 for the chain rule. So to prepare for that negativity and make sure I get positive 3e to the negative t when I take the derivative of g prime, to get g double prime, I need to put that negative there. Plus, and then I know how to antidifferentiate t at this point. That's 1/2 t squared, and then plus c. So, but g prime of 0 equals 3. -3 times e to the -0 is just e to the 0 is 1, plus 1/2 of 0 plus c. So -3 plus something equals 3. That's telling me c equals 6. All right. Then I'm ready to anti-differentiate once more to get regular g, or at least something I could use to find regular g. And this will be positive 3e to the negative t, because I just need to divide by that -1 again, because that's the only thing that's really going to be changing as I take derivatives of 3e to the negative t or -3e to the negative t. This one, I'm going to bump up the power by 1 and divide by the new power. So if I had a half and then I'm again dividing by 3, I'll be left with a sixth. Plus 6t plus c. Now I'm going to go over here and actually compute. What did it say? G of 0 is also equal to 3. So 3 equals 3 times 1 plus a sixth of 0 plus 6 times 0 plus c. I think this is telling me that c needs to equal 0, right? Because 3 is 3 plus c. Yeah. So my conclusion is that g of x equals 3e to the negative t plus 1/6 of t to the 3 plus 6t plus c. Right. Oh, that's a good one. Okay, this terminology, I don't think I did a very good job of talking about this in lecture, but basically, we're finding f of x if f prime equals, because you know that dy dx, that means f prime. F prime is secant squared x, and f of pi over 4 equals, is that 1 or is it, oh, it's 10. All right, I'm going to anti-differentiate to find f, or at least something close to f, and it's like derivative equal to secant squared x. It's going to be tangent x. And it's something you need to start knowing. Okay. F is equal to tangent x plus c. And so what I'm going to do is I'm going to plug in the point I was given right there to find out what that value of c is going to be. And so I'll say, well, all right, I'm going to plug in 10 for, oh, that wasn't true. That wasn't what the problem said. It said f of pi over 4 is 10, not f prime. Pardon me. Okay, so f equals 10 when x is pi over 4. All right, now pi over 4, I need to go over here and draw you a kind of a diagram, trigonometry diagram. Pi over 4 is over here at that 45-degree angle, so it's going to have a 45, 45, 90 triangle. And we know that on the unit circle, you know, all of them have hypotenuse 1. And for 45, 45, 90, the legs are root 2 over 2. And since I'm in the first quadrant, everything's going to be positive. And this is pi over 4. Okay, now the tangent, SOHCAHTOA, opposite over adjacent, same thing divided by same thing, that's going to be 1. Okay, so I'm going to say 10 equals 1 plus c. That's telling me that c needs to equal 9. And I'm going to conclude that f of x, the thing I was hoping to find, is equal to tangent of x, then add in 9. All right. The find a second degree polynomial problem. This one's going to be on the quiz. The thing about a second-degree polynomial that I guess I'll just say right now because I didn't say it in class. The second-degree polynomial is like y equals ax squared plus bx plus c, right? And if I take the first derivative, I'm going to get a line. That's 2ax plus b, which, by the way, is where the vertex happens at x equals negative b over 2a comes from. So it's the place where the slope is 0 on a parabola from Algebra 1. I think I mentioned that earlier on in the year, but in case I didn't, I need to tell you that. And then the second derivative with respect to x both times is, well, the derivative of 2 times a times x is just 2a, and the derivative of b is a number, so that's going to be 0. So this is just a number. Okay? Meaning that the second derivative for any second-degree polynomial will always be a constant. So in number 14, where they tell me p double prime of 0 equals negative 2, that might be kind of hiding the full picture, right? Because we know that p double prime of x needs to equal negative 2 for all x. Okay? And so now I'm going to say, all right, well, p prime is equal to negative 2x plus c. And they told me that p prime of 0 equals 1. So I'm going to say 1 equals negative 2 times 0 plus c. So c is 1. Negative 2x plus 1. And then I'll antidifferentiate one more time to find p. And that's going to be negative x squared plus x, right? I increase the power by 1, divide by the new power. Increase the power, that's like x to the 0. Increase the power by 1, divide by the new power. This is going to be 1x to the first divided by 1. Okay, and then don't forget that plus c. And then they told me that p of 0 is equal to 5. So 5 equals 0 plus c. I think that means that c needs to equal 5. And I'll say that p of x is negative x squared plus x plus 5. All right, number 15 is pretty similar. It's like the polynomial with a given derivative. Okay, so I know that if it's going to be a polynomial and its derivative is third power, it's going to be fourth power. Okay, so r prime of x equals 12x to the 3, meaning r of x equals increase the power by 1, divide by the new power. 12 divided by 4 is 3. And you can also check to make sure that works with the power rule. That'll be quick enough. Plus c. R of negative 1 equals 6. Okay, negative 1 to any even power will be positive 1, so 6 is 3 plus c. That's telling me c needs to equal 3. Okay. And, oh, it's just find r of x. Okay, well, r of x equals 3x to the 4 plus 3. Okay, now we've got some motion questions. That'll be good for us because, right, we know that now that we know how to anti-differentiate, we might recover a position function from a velocity function. So this one's number 16. V equals 2 minus 6t squared. If the position of the particle is negative 1 at time 0, so also given as x of 0 equals negative 1, what is the position of the particle at time t equals 2? Okay, we'll have a different, debatably better way to solve this problem, in the next unit once we learn about the fundamental theorem of calculus. But for now, what we need to do is we need to find x of t using our initial condition and then just plug in 2. So I know that x of t is the antiderivative of velocity with respect to time. So I'm going to say this is the antiderivative of 2 minus 6t squared with respect to t, which is going to be, okay, 2t, minus, okay, increase the power by 1, divide by the new power. 6 divided by 3 is 2. And there's plus c. Okay, maybe I'll switch the color up to find that c, but because x of 0 is negative 1, I'll have negative 1 equals 2 times 0 minus 2 times 0 to the third plus c, so c looks like negative 1. So now I know that x of t equals -1 plus 2t minus 2t to the 3. And if I'm interested in x of 2, the position at time 2, I'm going to have -1 plus 2 times 2 minus 2 times 2 to the 3. That'd be a safe place for us to stop. Because I know you all know how to compute that number. Right, let's see if that'll work. And number 17. I gotta be getting close to the end here. Yeah, cool. Number 17 is going to be an object moves along the x-axis so that anytime t, a of t equals -12t. So I know that velocity is going to be the antiderivative. I'm going to, I don't know, approach this one slightly differently. That's going to be -6t to the 2 plus c1. And then x is going to be, well, I guess I should probably, I need to figure out what c1 is first. But I know x is going to be -2t to the 3 plus c1x plus c2. Right? Then we can just kind of plug in and solve for c1 and c2. But, okay, at time t equals 0, its velocity is 8. Meaning, okay, 8 equals, okay, time was 0, so c1 needs to be 8. So x is -2t to the 3rd, increase the power by 1, divide by the new power, 6 divided by 3 is 2, plus 8t plus c2. And then, okay, well, at time 0, the position is 5, so 0 plus c2 equals 5, and that means c2 equals 5. Okay. And what was the position at time 1? That's -2 plus 8 plus 5. Right. Oh, I like this. The last problem. I'm not super into number 18, but I will work it because I'm committed to working all the problems for you. Okay, object moving along the y-axis is accelerating at 10t minus 1. Okay, meaning velocity is 5t squared minus t plus c. At time t equals 1, velocity is 3. Okay, so 3 equals 5 times 1 minus 1 plus c. So that's 4 minus 1 equals 3. That means c equals -1. Okay. All right, so x is equal to, antidifferentiate, increase the power by 1, divide by the new power. Okay, the same over here, increase the power, divide by new power, minus t plus some other new c. And then we're saying that at time t1, the position is 7/3 is equal to 5/3 times 1 minus half of 1 minus 1 plus c. Oh, man. Let's turn this all into sixths. I'm going to say that's 14 over 6 equals 10 over 6 minus 3 over 6 plus c. Yeah, that's the thing to do. So c is going to equal 7 over 6, right? Because 7 over 6 plus 7 over 6 equals 14 over 6. And now, oh, whoops, this is not x of t. This is an object is moving along the y-axis. I just read right past that. So that'll be a y. V of t is there. Y of t is going to be that. Okay. And the last problem I've got for you is find a function h of x with h double prime of x equals 2x and a horizontal tangent at the point where x is 2 and y is 1. Okay, horizontal tangent at 2, 1 means that f prime of 2 is equal to 0. But what's also hidden in here is that since the tangent is sitting at 2, 1, that means that f of 2 is equal to 1. Okay, so those are my initial conditions. They're just a little hidden. So I know I can anti-differentiate to get h prime. And it was positive 2x, so that's x squared plus c. Okay, whoops. These are supposed to be h's. And what am I saying here? Oh, yeah, h prime of 2 equals 0. So I'm going to plug in 0 equals 4 plus c, and c equals negative 4. So this is x squared minus 4. So h of x is what I get when I anti-differentiate this thing, and I'm going to get 1/3 x to the third minus 4x plus c. Okay, then I'm going to solve for the c by plugging in, oh yeah, h of 2 equals 1, which might not equal c, but 1 equals 1/3 of 2 to the third, so that's 8/3, minus 4 times 2 is 8. I know I'm going to need to go into thirds, so, and that's going to be 3/3. So if I add over here, that'll be 27 minus 8 is 19. That feels off. Let me see what I got. Sure enough, 19/3. All right, so h of x equals 1/3 x to the third minus 4x plus 19/3. That's all I got for you for this video.